This conference will now be recorded.
Hi everyone, welcome to the webinar on AWS Amazon Web Services from an architectural and DevOps standpoint, presented by Educado. So Educado is a very fresh young startup on education sector, and in Educado the trainings that are provided are not at all is really different from the others. We don't provide usual on the line training, but the trainings that are provided are completely project based. So if you consider joining any of our courses on AWS, for example, Amazon Web Services, from day one, you will be actually working on hands-on projects and learning the theory as well. So it's a different kind of training institute. Um, that is what Educado is. So with that in mind, let us start today's webinar. Today's webinar, we are going to keep it short and crisp because I know it's a Saturday evening and everyone has a plan. So we are going to keep it short and crisp. We are going to start with basics of cloud computing, then slowly understand what AWS is and what is the scenario of AWS, and then quickly go through in brief the DevOps offering in AWS. With that in mind, let us start the webinar. My name is Amit, and I am working as a cloud architect in AWS, Azure, and Google Cloud platforms. My specialization is designing data architecture, data solutions, machine learning, artificial intelligence solution in the cloud in a scalable and fault tolerant manner. So that is about me. So let's start our webinar. So please let me know if you have any problems in hearing or if you have any questions, but I'll prefer that we have half an hour or 50 minutes of webinar. After that, we will open the forum for questions and your specific needs. So as discussed, the agenda today is we'll be covering cloud basics, then we will be having a look at AWS basics, followed by basic service categorization, then AWS certifications, that what are the leading certifications in the market and why you should get them, and AWS cloud architecture and DevOps learning path, and how Educado can help you. Now, one thing is that since you are all have come for the webinar and decided to spend the next 40-50 minutes of your life in this webinar, I am sure you all know the importance of AWS and the importance of if you are a AWS architect, uh, the importance of getting into the AWS market. I'm sure you all know this, right? So I will not stress much into why you should do AWS, and I guess you all now know that AWS is like has captured like 70%, 75% of the cloud market, is the cloud leader for the last 5-6 years. It has always been the Gartner cloud leader, and is way ahead than all its competitors. The other competitors of AWS, close competitors of AWS, is Azure and Google Cloud Platform, but AWS is miles ahead on this. So if we consider, so let's consider cloud computing first. So if we have to define cloud computing, we would define cloud computing as a model where users have a convenient on-demand network access, or shared to a shared pool of resources such as servers, storage, applications over the internet. So when I say utility computing, it's a kind of utility computing. When I say utility computing, is just like your electricity usage in your home. So you pay only for what you use, and it is completely on demand. Like if you want to switch on 10 appliances in your house that is consuming electricity, you can do that. If you want to shut down, if you shut down two of those appliances, you will be only charged for the remaining 8 appliances, and so on and so forth. So cloud computing is a subset of utility computing, and we can define it as a convenient on-demand access to a shared pool of resources such as server, storage, applications over the internet. Users don't have a control of underlying hardware infrastructure that is owned and managed by the provider. They access the services allocated by the resources by using a web browser, or maybe the most convenient way, of course, is to use a web browser. The other ways are to use a CLI or a SDK or a API, etc. Now, cloud computing has like several definitions, but according to NIST, that is the National Institute of Standards and Technology, the five salient features of cloud are on-demand self-service, okay, where a consumer can set up computing capabilities such as server time and network storage as needed, and automatically without having any direct communication with each service provider. Broad network access, so capabilities are available over the internet and access through normal mechanisms that are used by various devices such as mobiles, phones, anything you can use, right? Then is the resource pooling. This is another very important aspect of cloud computing. The provider's computing resources such as storage, processing power, memory, right? Network bandwidth are pooled to serve multiple consumers. That you are also using your company. If company A is also using, company B can also pool those resources by using a multi-tenant model. So all the clouds, of course, supports a multi-tenant model. Tenant means organization, simply speaking. Further, on the basis of consumers' demand, various physical and virtual resources are systematically assigned and reassigned. Now, there is a sense of location independence in that the consumer generally has no control or knowledge over the exact location of the provided resources, but this is always not always true. When in AWS, we will see that there are regions and availability zones where you know where you are, in which region you are porting up or you're booting up your resource. Another very interesting characteristic of cloud is rapid elasticity, where cloud computing capabilities can be systematically provisioned to meet demand and load requirement. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated at any point of time, and you only pay for that. Okay. And measured service. Obviously, all cloud systems can automatically control and optimize the use of resources by a metering capability. Like whatever you use, you only pay for that. So that is basically what NIST defines as cloud computing. Now, why are we at all interested in cloud computing? Why are we at all like why do we at all believe, or companies are so much hiring cloud architects? You can see, right, hiring cloud architects, hiring cloud engineers, cloud network engineers, etc. Why there is so much of a hype of cloud computing? We will see that in the next section. So simply cloud, as of now, whatever we have discussed over the past 5 minutes, it summarizes to fundamentally the cloud is simply computing as a utility. Now let us see that what are the types of cloud. Now, type of cloud can be judged, or can be cloud computing itself can be categorized into two things. One is in the deployment model. What is the deployment model of my cloud computing or cloud architecture, or from the type of cloud that you are using, right? So let us start up with the basics of what are the type of clouds that we are using. So there are three. If you see in the market now, there are three kinds of, or three types of cloud that we are using. The public cloud, like for example AWS, Amazon Web Services, Azure, Google Cloud Platform, Oracle Cloud, IBM Cloud, Rackspace, okay, DigitalOcean. These are very important and significant examples of public cloud. So what is a public cloud? The cloud accessed or used by general masses and hosted and maintained as well as managed by the cloud service providers like Amazon, Google, Microsoft, whatever example I gave you. So these are public cloud. So due to this, initially small organizations that can start using cloud services, not only small, like people are like enterprises are going on to public clouds now, that can expand. And even since the COVID is there, that this will change the business scenario completely, and cloud will become actually the game changer of many business, right? Even banks are going in cloud now. During expansion, there is no need for the organization to invest in infrastructure and can pay just according to what is used. So in the public cloud, there is no need for organizations to control or manage the resources. Now, next comes the private cloud. In private cloud, the computing infrastructure is solely designed for a single organization and cannot be accessed or shared with the other organizations, right? So a private cloud can either be on-premise or hosted externally. In case of on-premise, the service is exclusively used and hosted by a single organization. However, private clouds are hosted externally and used by a single organization and not shared by other organizations. So organizations define their own cloud infrastructure. And there are something known as a community cloud, which is not that popular till now, but obviously it will come soon. So the community cloud is a type of cloud that is shared by various organizations with a common tie-up. Okay, so another kind of cloud you can say is hybrid cloud, which is a mixture of private and public cloud. And you will see that 80% of your project you will be using private cloud only, sorry, hybrid cloud only, where some part of your application will go on the public cloud and some part of application will stay on the data center. Having said that, there is another cloud computing service delivery model, as I told you. So in this slide that you're seeing is actually the service delivery models. So how can we classify that? So the first comes as infrastructure as a service. So I'll just take a quick check before we continue, guys. Yeah, I hope you can all hear me clearly.
Yeah, all good. All good. Yeah.
Thank you for the confirmation. I just, because some new people joined, so I had to take a brief interrupt our flow and take a good confirmation. Thank you. So there are three high-level cloud models depending on what resources you use and the benefits you get from the cloud, right? So the first is, as you can see, infrastructure as a service. So here you simply rent a virtual server. You just rent a metal box, okay, and you get it with a operating system. That's all. And in cloud we don't usually call it an operating system, we call it a machine image for certain reasons. So that is all you get in infrastructure as a service. So in this model you can either use servers or storage in the cloud, and in this model you do not have to purchase and maintain your own IT hardware. However, you need to install your applications on your cloud-based hardware resources. So you are responsible for your application and the platform in which the application will be installed. Next is the platform as a service. In this model, you can use the cloud as a platform to develop and sell software applications. Like for example, in Amazon Web Services, you have Elastic Beanstalk, which is example of a platform as a service, and in Azure, you have Azure Web App, which is an example of a platform as a service. Then we have software as a service, and in this model we can use various software applications like CRM, ERP, collaboration tools on the web. You save by not having to buy or maintain IT hardware or applications. Like for example, the most common example that comes to everybody's mind when hearing software as a service is Office 365 by Microsoft, and I'm sure your organization have moved into Office 365 from standard Azure Active Directory installations, etc. And the second example is of course Salesforce.com, which is the most common CRM product in the tool in the market now, and it is completely offered as a software as a service. Now there is a fourth type which I have not included because it doesn't really come under the service delivery model, is business process as a service. And in this model, you combine in this combined model, it includes a human capital management and ERP, supply chain management, vendor management, something like that. It's not a very generic tool, but it is specific to a business process. So that is business process as a service. So this is how we have to define our types of cloud computing in terms of installation, or rather I would say in terms of architecture and in terms of the service deployment models. Okay. So I hope this is till this I am okay and I have covered. So what are the typical use cases of IaaS? The typical use cases of IaaS is application hosting, backup and storage, content delivery, right? Databases. So you can take a IaaS and then you can just install and maintain your own database, etc. And then e-commerce applications, enterprise IT. So wherever you want to deploy your own, you want to create your own application without using the cloud native services, you can use in IaaS. So in IaaS, one particular thing of one particular vision is scalability. because in IaaS, whenever you are designing an IaaS infrastructure or IaaS related architecture for your cloud, you should always have the capability of automatically scaling up and scaling down machines as needed. Scalability will not come free. It will, obviously you will be charged for scalability, but you can be rest assured that AWS will take your scalability, take your application scalability. You have to design it in your application, and Amazon EC2 can auto scale, but your application definitely has to support it. So that's the scalability vision of your of a IaaS. So here, as you see, is a very high level architectural diagram of scalability architecture with IaaS. So suppose we have a instance one here, and we have instance one, instance two, instance three, instance four here. So if instance one, the instance one was first booted up, and then due to some reason, say this is an application which sells Christmas greetings card, right? And in Christmas you saw that the load is too much in this particular instance, so you can define metrics in this instance to linearly scale this instance one into three other instances which are interconnected with AWS networking and can which are interconnected with AWS networking in the same VNet or in the same subnets, and are monitored together and host the same application for scalability. The next comes reliability. So if the machine in your instance goes down, reliability means that what is the reliability means what is the guarantee, right? How much reliable is my Amazon Web Service, and what is the guarantee that I'll get back my data or my application data if my instance goes down. Now they are giving a guarantee to you in EC2, which is the AWS Amazon Web Services virtual server. They're giving a guarantee to you that your instance will be 99.95% available, and the storage will be 99.79, right? Total of 11.9% durable over a year. So that is the reliability part of your infrastructure as a service in AWS. Obviously, security is a high key point in any cloud architecture. So ongoing concerns about security, it's partially based on the lack of physical control, since you cannot control physically the cloud server. So you have to always be in your toe while designing the application with AWS. When security comes into play, the cloud provider does not have a master key to your server, okay, and access is generated always from your private key. So all these things are related to security, and in cloud there are mainly three kinds of security that you have to keep in mind while designing the solution architecture. One is the application level security, and one is the network security. So application level security is handled by mainly Azure Active Directory services, or other federated services, where you have dynamic or static user groups. Then your users are allocated dynamically depending on the location from where they are logging in, or depending on some other parameters. And then the application level security is authenticated by service principals and managed identity, which are automated services to actually let your solutions know that which service is allowed to actually call your solution and which services are not. So this is automatically controlled and managed using service principals and managed identity. So most providers support simple firewall type, but nothing complex. If you want any complex firewall installation, you can use a Bastion server along with your EC2 server or Azure virtual machines to go for higher level of advanced security and firewall. Hybrid cloud, we will always be mostly we will be using hybrid cloud in our uh, in our uh, in our actual project work. So we use our own local infrastructure to save some money, but not only to save money, but also for data security and also for compliance purposes, etc. And ideally with the same infrastructure support for VMware, Eucliptus, which is open source Amazon compliant cloud, but that can be a bit challenging to integrate best from both the worlds because of security reason, network bandwidth, and other architectural constraints. But obviously, like most of us always use hybrid cloud while working from on-premise to cloud migrations or applications that are distributed over on-premise and cloud. Next, as we saw, is platform as a service. So you have essentially unlimited machine capacity in platform as a service. There is no need to spin up new machines, or there is no need to spin up any new machines or any kind of infrastructural requirement like networking, storage, etc. Those you don't have to actually bother about. It is completely taken care or handled by the cloud provider. But you have to take the responsibility of your application. Okay, that application you have to be responsible, and all other things will be actually controlled by the uh, by your service provider, either your Amazon service provider, AWS or Azure or whatever. So you just, the platform is also provided. You just have to bring your bring your cloud into that, and then bring your application into that, and you have to define how your application will be scaled, how the security will be working, etc. Okay, so it also, like, if you see platform as a service, it also contains some other important points, that is the deployment automation. Because when you will be using platform as a service, obviously, since you don't have control over infrastructure, you obviously you will be wanting your application to be automatically deployed. Self-service features in cloud deployment also you will be wanting. Then federated cloud deployments, cloud performance monitoring and tuning will also be very important when you deploy it in a as your application as a platform as a service. Then in AWS software deployment, we have Elastic Beanstalk and Code Deploy, which are used for software deployments in AWS. It supports automated scaling, load balancing, built-in support for email and authentication, federated authentication rather, scheduled tasks and queues, persistent storage. And you can deploy applications in any language. Like if I'm correct, AWS supports Java, Go, Python, .NET, Node.js, JavaScript applications, etc. Control. How do we control our cloud environment? So as we have started our webinar, we told that cloud environments can be controlled either via your web UI, which you'll be getting when you open an account in AWS. I'm not sure how many of you have seen it, but it can be controlled via web UI. And secondly, or it can be controlled via API and SDKs that AWS provides, or via command line interface. So if you want to have more control, you need to obviously use APIs. Amazon API is known as Boto3. It's proprietary. Rackspace founded OpenStack API, and you can, since you're using REST API, you can obviously use any language that you wish. And in our course, for example, in Educado, though the course is focusing on AWS Architect certification and the AWS DevOps certification, but we make sure that we include modules on Boto3, because calling the API from a Python language and doing some automation in the cloud is a highly desirable skill in the industry now. Like, these are some of the type of operations that are automatically done in the industries using AWS APIs. Create the servers, not only servers but other services also. Get the server detail, update the password, delete the server, reboot the server. That is manage servers or manage any kind of services that can be used in AWS. Load balancing, provisioning, etc. So here I have summarized a functional architecture of whatever we have discussed over the past 15 minutes. So we have, first of all, we have infrastructure as service, which are basically the virtualization of bare metal, and gives you only the infrastructure. You have to bring in your platform as well as your application. Then comes platform as a service, where you are given the platform along with the infrastructure, along with the infinitely scalable infrastructure, and you can bring your application and deploy in that platform. Or you have service value nets, which is basically software as a service, where the entire software is built for you. You just have to configure and start using it according to your own business requirements. What are some of the architectural characteristics of cloud that we have discussed? The common characteristic means the common characteristics are massive scaling, resilient computing, homogeneity, geographical distribution, virtualization, service orientation, low-cost software, and advanced security. The essential characteristics are on-demand self-service, broad network access, resource pooling, etc. Now, with that in mind, we will shift into the second part of our session, which is DevOps, and why we have targeted for a course in cloud as well as DevOps together. So before I start the DevOps section of the course of the webinar, can I have I'll just open the platform for if there is any questions regarding whatever we have discussed till now.
Yeah, hello.
Yes, Tanmay.
Yeah, could you please explain a bit more on the load balancing part of this AWS, if possible?
Yeah, sure. So AWS EC2 instances supports load balancing via elastic load balancing solution, and there are several types of load balancing in AWS. The application level load balancing, the network level load balancing, or generic load balancing. And basically, it is for internal load balancing on the EC2 servers. For any external application traffic, you also have to use services like Traffic Manager, Front Door, or say or API Gateway, Application Gateway for any external traffic redirection, etc. But for internal load balancing, ELB or Elastic Load Balancer is used.
Yeah, understood. Thank you.
Okay, so if there's no more questions on this, let us move into the DevOps part. So DevOps, first of all, let me clarify the concept here. DevOps is not a tool, not a technology, not a platform. Okay, DevOps is a culture. It's a culture of bringing the development and operation team of an organization together to work together so that we can deliver software faster, and we can deliver software with higher quality, reduce our release cycles, and hence get feedbacks more faster. Okay, so that is what DevOps is. It's a mixture of process, tools, and culture together to change the way our organization works and bring the development and operation teams together, incentivize the development and operation teams together. So that's what DevOps is. So what it means that we are combining infrastructure, technical innovation, and business agility together, smashing them together into a mixture, and we're using that to deliver software faster and with more quality, reduce our cycle time, and increase our customer feedback, the cycle time of customer feedback. AWS DevOps. AWS has a wide range of services for supporting DevOps in an organization. So it starts with the source code control, supports build, automated testing, automated deployments, and monitoring. So when I say automated deployment here, AWS in turn supports two kinds of automated deployment. Server, one automated deployment, you have to take care of the servers, and in another kind of automated deployment, the very automated deployment, the very servers even are taken care by AWS. So there are two kinds of automated deployment that AWS supports. Let's see the services. So for the source code management, we have AWS Code Commit. For the build, we have AWS Code Build. For testing, we have AWS Code Build also, and it can be integrated with third-party test suites or test cases. For deployment, we have AWS Code Deploy. Now everything is stitched together to provide a continuous integration and deployment pipeline by AWS code commit, and the application lifecycle is monitored using AWS CodeStar. So this was regarding the AWS DevOps scenario. Now let me jump into the course structure, into the AWS course structure that we have. But first, I'll just open the forum for a quick question answer before jumping into the course structure. Questions, please. Okay, so let us see that what is our course structure. So we call our course AWS from ground zero. We don't assume that you have any AWS or DevOps background. It's here is a small typo. It's not 20, but it's 30 hours of hands-on course. So please excuse us for that. So it's a 30 hours of hands-on course where you will be learning about cloud principles, practices, and strategy on AWS. The certificate that we will be targeting is the AWS developer and architect certification, along with the DevOps specialization if you want to go for it. It covers the basics of cloud to an array of essential AWS services. We cover migration to AWS from on-premise also. So as we told you that from day one, you will be having a glimpse of projects. So we will be giving you hands-on assignments and architectural discussions from day one. After giving you after having spent like 2 hours per day in theoretical lecture, and by the time you come back to day two, you have to complete those assignments. Like, of course, it's your choice you complete or not, but we cannot force since it's a professional course. So you have to complete those assignments and hands-on projects before you come to day two. If you complete the course all the 15 days, if you complete the course according to how we train you, and how we and complete all the assignments, etc., then it's a surety that you will be passing in the certification exams and getting the AWS certificate. Of course, we will be helping you with that. Also, one thing we'll be helping is interview support, so that we know that you're learning for interviews or to make a move in your career. So we will be helping you in that, and whenever you have an interview coming, you can always approach us, so that we know we will tell you the best way so that you can clear it. So this is the suggestive course structure and plan. We will start with cloud basics. We will move into identity and access management. We'll move into EC2, where we will deal with Linux and Windows instance, AMIs, EBS, security groups, etc. Then we'll move into object-based storage using S3 and DevOps services. Sorry. Then the RDS, and we will talk about Docker and Kubernetes and AWS integration and messaging services, AWS serverless, and VPC. So that is what we will be covering in this entire course, along with DevOps services. So after this course, you'll be ready to take either in the AWS architect examination along with the DevOps specialization. So this is what I had to discuss today in the webinar. I kept it short deliberately because I don't want to waste much of your time. It's a Saturday evening, so I'll open the forum for questions. If now, any questions regarding the course structure or anything we discussed in the webinar?
Just one question from my side, Jyotirmoy here. I wanted to check, like, is it mandatory for us to go through a developer, then a architect program, or we can directly go into the architect program?
No, it's not mandatory. AWS has a level of certification. Let me explain you with a slide that will be better for me. So let me explain it here. So AWS has this kind of certification layer. So it starts with It starts with the associate level.
Okay.
It starts with the associate level, where depending on your experience, you can either give the developer associate or the system administrator or associate, which we are not covering. SysOps we are not covering, to be very honest. And because SysOps is mainly for infrastructure guys. And then you have architect associate. So there is no prerequisite for appearing on any one of these, but we suggest people to appear because we have seen the market, and we suggest people to basically appear for the developer and the architect, and our course will deal both with developer and architect. Then once you have done that, what you can then next do is, then there is a professional layer. Okay, professional layer, and in that there are various specializations. So you can be an architect, again you can do the professional architecture, you can do DevOps, you can do machine learning, you can do data analytics, you can do networking, or you can do security. Okay, so in this course we will be covering the developer part of associate, architect part of associate, because these two have almost 70% common syllabus, and then we will cover the DevOps part. So the highlighted parts will be covered in the course.
Okay. Got it.
So do you guys have any more question?
Just last one. Do you have a course fee structure with you? How it is designed and planned?
I am not the right person to comment on that. You can contact Manish, will contact you after this session or maybe tomorrow, and you can discuss with him.
Understand. Okay. Fair enough. Regarding the lab access, so will we be using our own personal instance, or it will be provided by if we go
Uh,
for the training?
See, you will be you will be doing it in your personal instance, because whatever lab you will be, I will be using my instance, for example. Whatever lab you will be doing in the class has to stay with you for long, so that you don't forget about it after you are got done with the course. But saying given that, we'll give you the recordings and all the lab files, obviously, and also along with that, whenever an interview comes, for example, we will discuss with you the JD, and then we will prepare you for the interview. We will tell you specific topics to again look at it, so that you are ready for the interview. Obviously, we cannot guarantee that you will succeed on the interview, because a lot of hard work needs to be done from your end also, but we will be helping you with what in whatever legal means it's possible.
Understand. Okay.
So thank you guys, and thanks once again to join in on a Saturday evening. I hope we all will meet in the class session that we are starting from September 5th. Um, so with that in mind, I wish you a happy weekend. Stay safe. Bye bye.
Same to you. Thank you.
Thank you.
Thank you.